We're taking a look at 14.1, which is about scatterplots and association, and this is the first module in the 8th grade where we actually get to look at some statistics and some data. So let's take a look real quick at what a scatterplot is. This first essential question asks us, how can we create and interpret a scatterplot? Now, all a scatterplot does is show you a comparison or a relationship between two different sets of data. I want you to think about back to our time of y equals mx plus b and slope-intercept form when we graphed relationships. Scatterplots really are just a scattering of dots that are plotted on a graph to try and show a relationship. The first question we're going to take a look at is about the final question on a math test, and it's comparing how many hours did a student study for the test, and we're going to compare that with the grade. So the two sets of data, we talked about two sets of data, the two sets of data we're going to compare are the number of hours that a student spent studying and their grade that they got. Okay, we're going to create a scatterplot here, and just like all of our other tables, this first column of data is usually going to be X, and the second column is going to be Y, and we always have Y depends. The grade is going to kind of depend, maybe, we'll find out how, on the hours that they study. So let's take a look. One of the things we can do is make a prediction. If somebody spends a lot of hours studying, we might anticipate that their grade will go up. And if they don't spend very many hours studying, maybe their grade would go down. Let's go ahead and create this dot plot or this scatter plot. This person right here spent 0 hours studying and they got a 75. So we're going to go just up 75, and that'll be the first dot that we create. This person spent a half an hour, so a half an hour is over to that line, and we're going to go up, they got an 80, and we're going to just scatter some of these dots on. Now, once we have the dots scattered on our graph, we can start to take a look at the relationship. And one of the things that we probably want to do is picture what would a line look like if it kind of went through all of those dots. And so I'm going to draw what's called a trend line. Now, I think my trend line kind of starts in here, and I think that these dots kind of tend to go up, even though this one is kind of down. You know, one of the words we give to a dot like that is we might call that an outlier, somebody that spent a lot of hours studying and their grade really wasn't that much better than somebody that studied less. But we're going to draw a trend line, and I'm going to sketch one, and it's kind of want to draw a straight dot, a straight line that kind of goes through the middle of all the dots. So one of the things that I notice is this has a positive slope, if you guys can remember. Slope man from our graphing days, this graph has a positive slope because it's going up. So one of the things that we can say about the trend is that if the hours of studying go up, the grade goes up. Now, when we look at scatter plots, the dot plot patterns are usually going to be one of three kinds. If I were to draw a trend line through all these dots, my line might start somewhere down here. And we want to kind of draw a straight line when it's a trend line. We don't want to draw curves unless it looks curved. This looks kind of straight. And if you can remember again from slope man, this is a positive association because as this quantity goes up, so does this quantity right here. Here's an example of a negative association. For example, as the time goes on, the number of people that stick around for, let's say, a meeting might go down. And if I were to draw a trend line, my line would go through all those dots and it'll look like that. Now, something like this where it's really just scattered around, there's not really a pattern here. We can't really draw a line through the middle of the dots and the dots don't show a pattern or a trend. So then we simply call this no association. Here's our first example of trying to interpret a scatter plot. It says Susan asked 20 people if they would buy a new product that she developed at these different prices. So for example, if this is $0, if this is 4, that makes this number right here would be $2. So we can say, if she asked them, hey, if my item costs $2, how many of you would like it? Well, all 20 people said they would like it because she asked 20 people. And then you can imagine that if I ask, hey, if I charge a little bit more money, maybe not as many people like it. Maybe here, this is 16. This right here would be 18. And so at $4, 19 people. So only one person said no. But then as the price goes up, here's $6. Now only 17 people want it. Now it's $8 and only 13 people want it. And here it is at $10. Now only 8 people want it. So we can say that as the price goes up, the less people want whatever it is that she's buying. And so we can say that if we were going to describe the association, it's definitely going down. So we say as the price increases, the demand goes down. As price increases, there would be less people want to buy what you're selling. And you can elaborate on that sentence if you like. Let's take a look and answer this question. What if she increased her price to $14? Well, there's 12, and you can see what the trend is doing, and my line kind of missed those dots. Over here is 14, and we almost might be able to say that this trend looks like it's just coming down. It's just going to fall. And if the cost is $14, well, at $12, we almost have only 2 buyers. So if it goes to $14, there probably won't be any buyers. Let's take a look at one last example from this lesson on scatter plots, and that is to look at this question here. The plot shows the reading level and the height for 16 students. So this side of the graph, the y-axis, is talking about how tall students are, and this one is talking about their reading level. So here's a student that is 45 inches tall and reads at the 6th grade reading level. And you can take a look at the dots, and this graph looks like it shows the dots are increasing because as I go to the right, which is getting bigger, the height is getting bigger. And so it's a positive association because that's what that side of slope man says, is that if a graph is going up to the right, it's positive. So it's a positive association. And then it asks for a possible reason. And one possible reason, if you guys could probably come up with a good reason on your own, one thing we could say, I guess maybe that taller people are better readers, but that's really not what this graph is showing because we're not talking about very tall kids. This is about 4 feet tall right here. And when we're talking about this, we're talking about elementary school children. And as they get taller, they get older. And as they get older, they probably are in a different grade. And of course, older kids are taller. And I think taller kids that are older are also going to read at a higher level just because of their age. So older students are in higher grades, and therefore they read better. And I think that that's a logical explanation for this scatter plot. But I'm sure if you got creative with your thinking, you could probably come up with a different explanation that would also explain this kind of a positive trend.